Okay, moving on to 9.9. Segment lengths from secants, chords, and tangents. So, we're going to study the properties of tangents and secants and the segment lengths that they make. If a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So, for example, find the value for x. So we know this is a right angle. Therefore, we have A, B, C. Remember, hypotenuse is always along the side. So x squared plus 12 squared equals 20 squared. So that's x squared plus 144 equals 400. 400 minus 144 is 256. And if we take the square root of both sides, x is equal to 16. Remember, hit pause if you need to. So, check to see if KL is tangent to OJ. Well, that just means A, B, C. 8 squared plus 15 squared equals 9 squared. And you should be able to tell right now that's not going to work. Why is that? What's wrong here? Is this the longest side? No, it is not. So that doesn't even make a proper right triangle. But let's do the math. That's 64, not equals, plus 15 squared, which is 225, equals 81. 225. 225 plus 64 obviously is not going to be 81. 289 does not equal 81, so no. And you may ask yourself, what if we switch the 9 and the 15? Well, still wouldn't work, because 64 plus 81 is 145, not 225. So it wouldn't work anyway. So that's a no. Moving on. Tangents to a circle from the same external point, right out here in space, okay, are congruent. So think of an ice cream cone. The sides of the cone must be the same length, or the ice cream cone will fall out. And we don't want that. So, find the length of AB. Same point in space, tangent point, tangent point. These are equal to each other. So we just do x plus 15 equals 3x plus 6. I'm going to subtract x from both sides and get 2x. Subtract 6 from both sides and get 9. And therefore, divide by 2, x is 9 halves, or 4.5. And we can check our work. If we plug that in here, 4.5 plus 15 is 19.5. And if we plug it in here, 3 times 4.5 is 13.5, plus 6 is 19.5. It checks out. Final answer. All right. Find a value for x and the perimeter of the polygon. So this one, for some reason, stumped me at first too. So we have an external point, which means this tangent right here is congruent to this tangent, which means this is 10. And then we also have a point out here, which means this tangent is equal to this tangent. And we have an external point out here, so this tangent is equal to this tangent. All right? Now, the one thing we don't know is x. We know these are both going to be x, but what is x? Well, we know this whole piece here is 9. If this is 5, that makes that 4. So we've solved for x. X equals 4. And the perimeter equals 15, 10 and 5, 14, 10 and 4, plus 9. Okay? And 15 plus 14 is 29, plus 9 is 38. So the perimeter is 38. All right. A little bit of a twist here. When two secant segments, and remember, secant goes outside the circle, are drawn to a circle from an external point. So they have to be starting at the same point out here in space. The product of one secant and its external segment equals the product of the other one and its external. So here's a secant, and here is the external. Here's the secant, and here's the external. So we have it did not show up. I don't know why. All right, so we're going to fill that in. So the outside times the whole equals the outside times the whole. And if you look at the letters up here, the whole is represented as little r, and the outside is represented as s. And on the other one, we have the whole represented as t, and the outside represented as u. So r times s equals t times u. Let's see it in action. So the whole is 12. The whole here is 6 plus x, whatever x is. If x is 2, it's 8. If x is 3, it's 9. So the whole, 12, times the outside section, 4, is equal to the whole, 6 plus x, times the outside section, 6. So this is 48 equals. Now, you could send the 6 in, but here's a little trick. Since it's on the outside being multiplied, we can divide. And that gives us 6 times 8 is 48. 6 plus x. Subtract 6, x is 2. And we can check that out. 6 plus 2 is 8. 8 times 6 is 48. 12 times 4 is 48. It works. Now, like I said, some of you may not want to get rid of the 6. Some of you might have sent this in, and that's fine. You would have gotten 6x plus 36. You subtract the 36 and get 12. Divide by 6 and you get 2. You still would have gotten the same answer. It's just how you look at the problem. All right, new concept. Similar. When a secant, S, and a tangent, T, are drawn to a circle from the same external point, the product of the secant and its external, same idea, is equal to the square of the tangent. Okay, it's a very similar idea. We're still going to take the outside times the whole is equal to the tangent squared. So again, we have the letters R and S equals T squared. So again, we need our total 24. Okay? 6 times 8, 6 plus 18 is 24. So the whole, 24, times the outside is equal to the tangent squared. Well, 6 times 24 is 144. We need the square root of both sides. X is equal to 12. All right. So we need, what we have here is 2 secants. So from the same point. So we're going back one rule. This is 12. 8 plus 4. And now we need the outside part right here. Well, let's think about it. If x was 2, the outside part would be 6. If x was 3, the outside part would be 5. So this piece right here is 8 minus x. Right? So, again, we take the total of the whole thing times the outside part equals the whole, 8 minus x, times, sorry, the whole is 8 times the outside part, which is 8 minus x. Now again, you could distribute this f, the 8 if you want, but again, we can do a little trick here. We can get rid of the 8, which we're going to get rid of eventually if we distribute it. We're just going to undo it, so it's creating more work if you distribute it, but it's up to you. 8 minus x. I subtract 8 and I get a negative number. That's bad. Except we have negative x. So we divide by negative 1, we end up with x being 2 again. Let's clean that up. I'll draw my equal signs. There we go. X equals 2. And again, if you check that out, that would make this 2. That would make that 6. 6 plus 2 is 8. 8 times 6 is 48. 12 times 4 is 48. It checks out. And that's it.